main purpose of the TPS is to monitor the position of the throttle valve, and converts the throttle valve angle position into a voltage signal, which is transferred to the ECM or PCM. The TPS sensor unit is mounted on the throttle body, either separated or integrated to the actuator motor. The TPS is mounted externally on the throttle shaft of electronic throttle body, ETB. Throttle body systems become more and more integrated in order to reduce system space and weight as well as material cost. TPS is integrated to the actuator motor in ETB. There are two major types of throttle position sensors: contact type, a potentiometer sensor, and contactless type, Hall effect sensor or inductive sensor. Potentiometers are a suitable solution for systems where low cost is key and reliability and safety can be traded off. Since the throttle position sensor is a safety-relevant application, most new sensors are based on contactless principles nowadays. In the dual resistive TPS integrated type, two separate potentiometers detect throttle valve position. In the potentiometer integrated type TPS, a multi-finger metal brush, rake, is in contact with the resistive strip. As the throttle valve opens, the two potentiometer metal brushes move across the resistive strip, changing the voltage divider circuit resistance values and sending the output voltage to the ECM. ECM supplies TPS with reference voltage 5 volt. TPS output voltage, TPS1 and TPS2 signals, changes with throttle position. TPS2 signal has a positive voltage offset of approximately 1.6 volt, as compared to TPS1 signal for a fully closed throttle. Contactless magnetic type throttle position sensor, TPS, works on the principle of Hall effect. The Hall effect TPS makes no physical contact, so will never be subject to failing by wear and have longer life cycles. Hall effect type TPS consists of Hall IC made of Hall elements, and of magnets that rotate around them. In magnetic TPS, a two-pole, SN, magnetic disc is fixed on the shaft of the throttle valve. Its angular position is detected by an IC sensor aligned to it, with a small air gap between magnet and sensor. The Hall effect IC sensor, and signal processing circuit board, is mounted within the electronic throttle body ETB gearbox cover and is stationary. The magnets are mounted on the throttle valve shaft gear, and rotate together with the throttle valve. When the throttle valve opens and the magnets change their position, the Hall IC detects a change in the magnetic flux caused by the change in the magnet's position. The resulting Hall effect outputs voltage in accordance to the amount of change. This signal is sent to the ECM as the throttle valve opening signal. This signal may be either an analog varying voltage signal, or a digital square wave constant frequency PWM signal. TPS1 signal has linear voltage increase with the throttle angle. At idle, TPS2 signal is offset approximately 1.5 V compared to TPS1 signal. One way of measuring a rotational position in a contactless way is by using an inductive principle. The contactless inductive type throttle position sensor consists of a stator and a rotor. Rotor inductive loop is the dynamic part which is mounted on the throttle valve shaft gear. A rotor is formed of one or more closed conductive loops with a certain geometry, and is made of electrically conductive material or by a printed circuit board, PCB, element. Sensor and signal processing circuit board is mounted within the ETB gearbox cover and is stationary. The stator comprises a standard printed circuit board, PCB, and an application-specific integrated circuit ASIC. The printed circuit board, PCB, includes planar exciting and receiving coils as well as evaluation electronics. Transmit coils send a signal, which is coupled back through a rotor into receiver coils. An IC is used to both generate the excitation signal and decode the received signal. The sensor output is flexible and can be both analog and digital, and redundancy can be achieved by integrating a second setup with a separate decoding IC on the same PCB.